Hi, welcome to this lesson in algebra word problems, solving a word problem, question 1. The length of the diagonal of a rectangle is 25 centimeters more than its width. The length is also 17 centimeters more than the width. Calculate the ratio of the area to the perimeter of the rectangle. So we're using the strategies of solving word problems. We've read the question fully. We now want to see, is there a key object in the question that is referenced a lot relative to other information? I see that the length of the diagonal is referenced to the width of the rectangle. I see that the length of the rectangle is also referenced with respect to the width of the rectangle. So let's call the width x. So in our rectangle ABCD, this width here and this width here are equal. That is by the properties of rectangles. Opposite pairs of sides are equal. So I can label them x and x. Right? What is another important property of rectangles? All the interior angles are 90 degrees. Okay. We were told that the length of the diagonal, which in this case I've drawn here as AC, is 25 centimeters more than its width. So mathematically, we can write that as the width plus 25 centimeters. So that is how long the diagonal is. The length was also said to be 17 centimeters more than the width. So these opposite pairs of sides here, which is the length of the rectangle, are x plus 17 centimeters long. Right. So now if we can solve for this unknown variable x, we can then find the area and the perimeter and then answer the question. Because I see a right angle triangle, triangle ABC is right angled, we can use the theorem of Pythagoras. So the theorem of Pythagoras says in any given right angled triangle, if the lengths are A and B and the hypotenuse, which is the side opposite the 90-degree angle, is given by C, then Pythagoras' theorem says that A squared plus B squared must equal C squared. So the square of this length here plus the square of this length here is equal to the length of the hypotenuse squared. So in triangle ABC, using Pythagoras' theorem, we can conclude that this length here squared, so x squared, plus this length here, so plus x plus 17 squared. Notice how I wrote the first full length in brackets, then square it. I didn't square each individual term because the total length of that side is x plus 17. And that's equal to the total length of the hypotenuse, which is opposite the right angle. In our case, that length is given by x plus 25, all squared. All right, so now we simplify this equation, x squared plus. So to square a binomial, right, we square the first term, so x squared, plus we can square the last term, so plus 17 squared, and then we take the product of this, which will be 17 times x, and we double it, so multiply by 2, right? That is one of the techniques for expanding out a binomial that is being squared. We can also write out the full expansion if you are not familiar with using the quick method first. All right, so on the right hand side, let us do it by expanding first so we can see. So x plus 25 squared is x plus 25 times x plus 25. If I expand it out, x times x is x squared. X times 25 is plus 25x. 25 times x is plus 25x. And 25 times 25 is 25 squared. All right, so let's clean up this equation a bit. I have an x squared plus an x squared. That'll give me 2x squared. Plus 2 times 17 times x. Well, 2 times 17 is 34 times x, so 34x. Plus 17 squared, we can do that on a calculator. It becomes 289 equals. Now on the right hand side, you got 1x squared. You got two amounts of 25x. That's where that double comes from, right? So 25 plus 25x, or 25x plus 25x is 50x. Plus 25 squared is 625, right? Which we can check on the calculator, right? Let's clean this equation up a bit more. So I'm going to bring all these terms to the left-hand side. So I'm going to subtract x squared from both sides. That leaves me with 1x squared on the left-hand side. 34x minus 50x. So there's more 50 here. 50x is more than 34x. So when I subtract it, it becomes negative 16x. Similarly, 289 minus 625, that gives me negative 336 equals 0. Now this is a quadratic equation and it's equal to 0, so it's in the general form that we're happy with. We could potentially factorize this, but since the numbers are quite large, I would say rather use the quadratic formula, because then we can just plug in the values and solve. So the quadratic formula, as we recall, is x equals negative b plus or minus the square root of this entire expression, b squared minus 4ac, which is otherwise known as the discriminant, b squared minus 4ac, over 2a, right? And what are our values? So a here is the coefficient here, which is 1. B is the coefficient in front of x, which is negative 16. And c is the coefficient, the constant, negative 336. So if I plug those values into this formula here, which is quite long, right? So I'll plug in negative, open brackets, negative 16 plus or minus, so negative 16 squared, minus 4 times a is 1, c is negative 336, square root, all over 2 times 1. Putting that into your calculator, you'll get two solutions, x equals 28 or x equals negative 12. Now, mathematically, these two solutions are correct and satisfy the original equation that we're trying to solve. But physically, it doesn't make sense to have a negative length. You can't have negative 12 centimeters in the length. So our solution that we take is x equals 28 centimeters. So now we can calculate the ratio of the area to the perimeter. So recall that the area of a rectangle is length times breadth, which in our case, so let's fill in these dimensions here. So this length is 28 centimeters. 28 plus 17 will give you 45 centimeters. So the width is 28 centimeters and the length is 45 centimeters. So the area will be the product of those two numbers, 28 times 45, divided by, how do you calculate the perimeter of any shape? You just add up all the lengths and widths, right? So that'll be 45 plus 45 plus 28 plus 28. So these are the two lengths and these are the two widths. So doing that on your calculator, and it'll simplify all the way down to 630 over 73. And that'll be our final answer. All right, I'll see you in the next one.